In the last lecture, JWST gave us a taste of exoplanet atmospheres. Now we push for the ultimate prize, a world with life. But the universe loves tricks and cheap imitations. A single gas won't cut it. We need a case so tight, so cross-examined, that only biology can explain it. This is the most careful detective work in all of astronomy. Pause and think. You detect oxygen, you detect methane. On Earth, this combination is a powerful sign of life because they react with each other and vanish unless something is constantly replenishing them. But is it possible for a completely dead world to fake this balance? The answer is yes, and that uncertainty is the core problem we have to solve. Think of it like a campfire that stays burning for centuries without any fuel added. It screams that someone is tending it. On a lifeless planet, oxygen and methane would annihilate each other in a few hundred years. Finding them together is like finding a perpetual fire. The only known fuel source capable of sustaining that fire over billions of years is biology. So what could fake it? A young, active star blasts the planet with UV light, breaking apart water molecules high in the atmosphere. Oxygen accumulates without a single living cell. Volcanoes erupting through icy crusts can release vast plumes of methane. Every potential biosignature comes with a plausible, non-biological alibi. Our job is to systematically eliminate every single one of those alibis before we make a claim. Here is the razor's edge, and the first thing to notice is how little there is to see. These are paired bars, a simulated dead TRAPPIST-1e beside a simulated living one at 3 wavelengths. Look how close each pair sits. That is the whole argument. The difference between a dead world and a living one, as JWST will actually see it, is a few hundredths of a percent in transit depth, a few parts in 10,000 of the star's light. The oxygen pair separates a little, the methane pair a little, and water barely at all. Everything else in this lecture is about earning the right to trust a gap that small. This isn't a hypothetical planet. It is TRAPPIST-1e, a rocky world, nearly the same mass and radius as Earth, receiving a similar amount of energy from its star. It hangs perfectly in the habitable zone of its ultra-cool dwarf sun. This is the world JWST will stare at for hundreds of hours. If there is a biotic signal out there, this is where we will either find it or learn just how small the odds truly are. Watch the rhythm of the system. 7 Earth-sized worlds, locked in a resonant gravitational chain, orbiting a dim red star. The inner worlds are scorched, the outer worlds are frozen. But right in the middle is planet E tidal. Locking means one side perpetually faces the star, a world split between burning day and frozen night. If life exists, it might thrive in the eternal twilight of that ring, the Terminator line. You are on the review committee. The oxygen and methane signal is in the data. What's the next check to push this toward a confirmed detection? Pause the video and commit to an answer. Really commit. The strongest clue is a quiet, old star with no carbon monoxide alongside the oxygen. Answer B, and notice that it does 2 jobs at once. The quiet star means low ultraviolet flux, which slashes the first abiotic oxygen source, water being split high in the atmosphere. The missing carbon monoxide kills the second one. Carbon dioxide photolysis also makes oxygen, but it makes carbon monoxide at the same time, in step, and it cannot help it. So if you see oxygen and no carbon monoxide, that route is closed. A young star floods the planet with UV and hands you oxygen for free. A thick hydrogen atmosphere means you are looking at a mini Neptune, not the rocky world we are searching for. Every detail either closes an alibi or opens one. Start with the standard of proof. A single gas is a clue. A disequilibrium pair like oxygen and methane is a lead. But a confirmed detection demands the full context, the star's age, the planet's geology, and the complete chemical census of its atmosphere. Second, you own the necessary skepticism. You know the imposters, UV-split oxygen, volcanic methane, false signals from hydrogen escape. The game is not just finding a signal that looks like life, but proving it cannot be anything else. Third, you own the frontier. TRAPPIST-1e is the best candidate for the first human discovery of life beyond Earth. JWST is already gathering its light. Next lecture, the future. the telescopes on the drawing board, the missions in development, and the vast questions we don't yet know how to ask.